the first question is, what is the importance of periodic table? So the question number 1 is importance of periodic table. So periodic table, it organizes elements on the basis of increasing atomic mass and atomic number. Organizes elements on the basis of increasing atomic mass. So it's a very systemic, it organizes very systematically. And so what is the advantage if it organizes systematically? The advantage is that it helps this organization, it helps to recognize physical and chemical physical and chemical properties properties of an atom, meaning that all the atoms in a column will have similar characteristics. So I am also recording this, so I will upload if the recording goes successful. Okay, so that's question number 1. Let's go to question number 2. And the question number 2 is that what are the respective charges on proton, neutron, and an electron? So, so where does this come from? So let's say if there is an atom, this atom has a central core particle. Central core particle that is called as nucleus. This nucleus is composed of 2 particles, number 1 and number 2. Number 1 is protons, which are positively charged, and second element present in, second particle present in the nucleus is are neutrons, and neutrons are neutrally charged. So, oh, it's hard to make it. So neutrons are neutrally charged. Now, so this is the nucleus. Around this nucleus is around the nucleus is revolving another particle. That particle is called as the circulating particle is called the revolving particle is called as electrons, and these electrons are negatively charged.
Let me put it this way. Where Canto had far more human development.
Electrons are negatively charged particles. So these electrons, they are negatively charged. Now the question comes, there is positive, there is neutral, there is negative particles. So what is the net effect? The net effect is that because of these particles in the nucleus, the atom becomes the overall charge on atoms are neutral. So neutral. So an atom is a neutral entity because the positive and the negative charge balance each other. Now let me give you a situation, just an example. Let's say there is an atom which has 14 protons, 14 neutrons, and 14 electrons, balance. So what is happening? Protons are positively charged, electrons are positively charged, electrons are negatively charged. So positive and negative, they balance each other. So 14, 14, an atom is neutral. The charges are balancing each other. Now let's consider a situation where this particular atom loses one electron. So let's say from 14, this atom became 13 electrons. So what happens? That there are 14 electrons and 14 protons and 13 electrons. So a positive charge is more on this atom. So the net charge on this atom, because of loss of an electron, the net charge on this atom is positive. The net charge on this atom is positive because protons are 14 and electrons are 13 because there's a loss of electron. So you don't say a positive atom or a negative atom. So the net charge on this atom will be this atom will become positively charged, and instead of calling it an atom, this will be called as ion, positive ion. So when an atom either loses an electron or gains an electron, it becomes a charged particle, charged entity, and that entity is called as ion. So let's consider second situation. Let's say the atom, instead of 14, the atom which has 14 electrons, there is a gain of electrons. So electrons number become 15. So 15 electrons, 14 protons. So 15 electrons, there's an extra electron. that makes this atom a negative entity. So this is a negative ion. So loss or gain of electrons in an atom generates either a positive ion or a negative ion. Okay. So the question was, what are the charges on protons, neutrons, and electrons? Protons are positively charged, neutrons are neutrally charged, and electrons are negatively charged. The net charge on an atom is neutral because protons and electrons, they balance each other. In a situation where an atom loses an electron, then it becomes positive ion. And in another situation where an atom gains an electron, it becomes a negative ion. So I went a little bit more with regards to defining electron, protons, and neutrons. So let's look at what's the next question. So the next question is, what is an atomic mass? So an atomic mass is mainly protons and neutrons. So let's say this atom has 14 electrons, 14 protons, 14 neutrons. So the net atomic mass will be 28. Now you can ask me a question, why don't we include electron also? So electrons, even if it is included, it doesn't really increases the mass because the mass of electron is very minimal. So atomic mass refers to protons plus neutrons. And what is an atomic number? Atomic number refers to only the number of protons. So let me just write this. So atomic number is equivalent to number of protons, and atomic mass is equal to protons plus neutrons plus electrons. But the mass of electron is very minimal. The maximum mass in an atom comes from protons and neutrons. So this took care of question 1, 2, 3, 4. Now the fifth question is, what are the atomic number and mass for atoms carbon, hydrogen, oxygen, nitrogen, and phosphorus? So the atomic mass for so each atom in a periodic table is represented by single letter, and in case of carbon, the atomic mass, in case of carbon, the atomic mass in case of carbon, the atomic mass is 12 and atomic number is 6. Okay. In case of hydrogen, which is represented by single letter H, atomic mass is 1 and atomic number is also 1 in case of hydrogen. In case of oxygen, it is represented by single letter O, and the atomic mass is 16 and the atomic number for oxygen is 8, right? Now, for nitrogen, it is represented by single letter N. Atomic mass is 14, and atomic number is 7. For phosphorus, atomic number is 30. Sorry, for phosphorus, the atomic mass is 30, and atomic number is 15. So I'm writing here carbon, hydrogen, oxygen, nitrogen, phosphorus, atomic mass 30, and atomic number 15. So this takes care of, I believe, 5th question. Now, 6th is what is the major difference between an atom and a molecule? So let's say an atom. So atom is the smallest the smallest particle of an element, whereas molecule is formed by when a molecule is formed by when two or more atoms they form a chemical bond. When two or more atoms form chemical bond, then it becomes a molecule. What could be an example? For example, oxygen gas. Oxygen gas is written as O, and 2 is a suffix written like this, oxygen atom. Now, the two atoms are similar here. So these kind of molecules are referred as homogeneous. There could be a situation such as a molecule, sodium chloride, which is a common salt. This molecule is made up of two different atoms. So this is a heterogeneous molecule, right? So an atom is the smallest particle that can exist by itself. A molecule is formed when two or more atoms, they enter into chemical bonding. Now, what does chemical bonding means? Chemical bonding happens when two atoms, they come in the proximity and they want to enter into a arrangement, a relationship. Why this chemical bonding is formed is to enhance the stability, right? So by itself, an atom could be not stable, but when it enters to form molecule, it becomes more stable. So that's the intention. That's the intention behind an atom going to form molecules, to attain more stability with respect to its existence. So that's the difference between an atom and a molecule. So let's look, that's atom and a molecule. Question number 7, what is the difference between an atom and an ion? So I mentioned to this in earlier, but I'll just say again, that an atom, two things can happen to an atom. Number 1 and number 2. In number 1 situation, an atom can lose an electron. An atom can lose an electron. In the second situation, an atom can gain an electron. So when an atom loses an electron, so you have to consider that atom is a neutral entity, equal number of protons and equal number of electrons. If it loses an electron, then the number of protons becomes higher. So when it becomes higher, the atom becomes positively charged. And then an atom gains an electron, so an electron becomes extra, more than protons.
Got they frozen drinks back.
Right? So that's the difference between. So an atom is a neutral entity, but because of loss or gain of electron, it becomes positive or negative. Positive or negative. So an atom is neutral, it is less reactive, and an ion is a more reactive because it's a charged molecule. Charged entity, an atom, not a molecule. So loss or gain of electrons transform an atom to become ions, which could be a negative or positive, depending upon whether an atom gains an electron or loses an electron. So it's a game of losing or gaining electrons. Question number 8, what are the four major biomolecules? So the four major biomolecules are carbohydrate, second is lipids or fats, third is nucleic acids, and fourth one is proteins. Okay, so I'm sorry. So that's the four biomolecules. So what's the next question? What is the chemical formula for glucose? So the chemical formula for, so let's look at this way. So let's look at so these biomolecules, in other words, they are large molecules, or they could also be referred as macromolecules. Large molecules that could be referred as macromolecule. Now, the beauty of this system is that these macromolecules, they are made up of repeating units. Just like a brick in a building, a simple building, They are made up of bricks and so units. So 4 biomolecules: carbohydrate, lipids, nucleic acid, and proteins. So going one step ahead, carbohydrates, they are made up of, the single unit is glucose, and glucose is written as C6H12O6. This is not the right way to write, but since this doesn't give me an option to write as suffix, so let's go to Google to see what's the right way to write. So let's say, what is the chemical formula for glucose? Right. So the glucose is, in real, it is written as C6H12O6. Six carbon atoms, 12 hydrogen atom, and 6 oxygen atom. So what is the total number of atoms here in a glucose molecule? 6 carbon, 12 hydrogen, 6 plus 12, 18, and 6 oxygen. So 6 plus 12 plus 6, 18 plus 6, 24. So 24 total atoms. How many different types of atoms? So 24 total atoms and 3 different types of atoms in a glucose molecule. What are the 3 atoms? Carbon, hydrogen, and oxygen. So now coming to lipids. Lipids are very diverse molecule. They have made up of saturated fat. They are made up of saturated fat or non-saturated fat. They are also cholesterol. They also have steroids. So steroids. So lipids are very, very diverse molecule as compared to carbohydrate. So many books, just on the basis of fat, they will say that lipids are made up of subunits such as fatty acids and triglycerides. But actually, the lipid molecules are very diverse. Now, coming to nucleic acids. Nucleic acids, the building block is nucleotides, right? And for protein, the building blocks are amino acids. Now on this table, on this slide, you have 4 biomolecules: carbohydrate, lipids, nucleic acid, and proteins. All of them are macromolecules. They are made up of smaller units, but these smaller units are more defined in terms of carbohydrate, nucleic acids, and protein, and less defined in terms of lipids. But if you look at a lot of metabolic or biochemistry book, they will say lipids are made up of fatty acids and triglycerides. Okay, so now one more thing I would like to add. So as a source of immediate energy, you feel hungry, you go and take a sandwich, you feel satisfied, you feel energetic. That energy, immediate energy, comes from carbohydrate. But let's say if we starve, then for starving duration, the energy comes from lipids. So carbohydrates are immediate source of energy. You have breakfast, you feel good. If you don't have breakfast, you feel slow or you know. But if you starve, that energy is sustained by lipids. And if you compare which is a better source of energy, then it is the lipids. Right? Carbohydrate is immediate energy, but lipids have larger amount of energy. Now in our body, what is that currency that determines energy, right? That molecule is called as ATP. And ATP stands for adenosine triphosphate. That's the currency for energy. Okay, adenosine triphosphate. So let's go to the next question. I told you the chemical formula for glucose. Draw the chemical structure of glucose. So,
What you doing? What you doing? I can hear you. Which one you doing?
So the chemical structure of glucose can be, I'm not making it on the blackboard, on the board, on the slide, because I don't have that much of tools to draw glucose, but glucose could be like this in a single chain. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5th and 6th. So 6 carbon, 12 hydrogen and 6 oxygen. So sometimes glucose is written as a linear molecule, and sometimes glucose is also represented by cyclical in a way. So it could be represented in a linear fashion. It could be represented in a cyclical fashion. You don't need to remember the structure of the glucose. You just need to know the 2 facts about glucose, that this is a building block for carbohydrate and it has C6, 6 carbon, 12 hydrogen and 6 oxygen. That's the chemical structure of glucose. Now question number 11. What are the functions of protein, carbohydrate, lipids, and nucleotide? What are the functions?
Okay, I got those answers already.
So 4 molecules, right? 4 macromolecules, proteins. So I would indicate E as protein,
Yeah.
C as carbohydrate, L as lipids.
Excuse me, whoever's mic is on, can you please turn it off so we can hear the professor? Thank you.
So proteins have many functions. They are the real workforce of our body. So proteins could be used for defense, right? These days, you're listening the word antibodies with regards to COVID. So what are these antibodies or antibody tests? So these antibodies help to defend us, our body, against a pathogen. What is pathogen? Is a disease-causing organism. So the antibodies that fight these pathogens, they are proteinaceous in nature. So defense is most important. Second is hormones, right? Hormones are important for growth of our body, our system, right? So then enzymes. Enzymes are those proteins. 99% of the enzymes are proteins. And what does enzymes do? They help in metabolism. Metabolism. It helps. Metabolism means let's say when we eat bread, the bread is broken down into ATP molecules. So starting from bread that we consume and then converting into glucose and then converting into ATPs, there's a process, there's a pathway. That pathway is called as metabolism. Enzymes are the central actors of a metabolic pathway. So defense system, antibodies, hormones, it helps in our development growth, enzymes, and also infrastructure. Cellular infrastructure. So proteins, for example, if you look at our body, a skeletal system, it has muscles and bones. Proteins are important component of muscles. So when you go to gym, there are many, gym trainers will tell you, consume more proteins, because proteins, they help to build our infrastructure, muscles and bone. And if you talk about single cell, there are some that we'll talk in mitosis and meiosis, microtubules. That is also part of. So these four are the major functions of proteins.
Okay.
Now, carbohydrates, the major function of carbohydrate is energy. Carbohydrate is the immediate source of energy.
Need to wash on my white shirt.
Now, what are the functions of lipids? The functions of lipid is that it helps in the formation of cellular boundary. What is that boundary? Cell membrane. Lipids are very important for formation of membrane.
Well, that's it.
Second, lipids are also a source of energy. Now, if I give you a question, which is the source of energy, better source of energy, protein, carbohydrate, lipids, and nucleic acid, then of course we'll pick up lipid.
Mm-hmm.
Right? If I ask you what is the immediate source of energy, then it will be carbs. And if I ask you what is the source of energy when we are starving, then it is lipids, because we are not consuming anything. Now, what is the function of nucleic acids. So nucleic acids are nucleic acids could be of two types, DNA and RNA. Now, it's very interesting. In majority of the organisms, DNA is the genetic material. Majority of the organisms. So genetic means that when we use the word genetics, it means hereditary, something that is passed on from our parents to our next generation, genetics, right? Now, in our body, humans, our genetic material is DNA that is present in our chromosomes. There are many organisms, particularly viruses, they have RNA as their genetic material. And some of those viruses are HIV and let's say COVID-19. They all have genetic material as RNA. So plants, animals, bacteria, mostly the genetic material is DNA present as chromosomes. RNA is also genetic material, and that is present in many viruses. And some of them are well-known viruses are HIV and COVID-19. So the overall role of nucleic acids are in hereditary, passing on information from one generation to the next generation. Okay. So that was question number 11th. Then draw the chemical structure of an amino acid named as alanine. So this I can try. This is straightforward as compared to a glucose molecule. So any amino acid, it is made up of a central carbon atom, and this central carbon atom is generally referred as alpha. Central carbon atom. Now this carbon atom is bonded in 4 ways. 1, 2, 3, and 4. Right? So now what exists here? So the first thing is hydrogen. The second bond is NH2. NH2 is referred as amino group. Amino group. The third is called as COOH. Third, this one is third. Third is referred as, I'm writing more clearly. Third is COOH, and this is referred as carboxylic group. So first is hydrogen, second is amino group, NH2, and third is COOH, carboxylic group. Now we know that proteins are, how many amino acids? Proteins are made up of 20 amino acids. Just like we have 26 alphabet in our English literature, 26 A to Z, And these 26, depending upon the word you want to make, these alphabets could make millions of words. And these words can be made into sentences. Sentences could communicate our feelings, our thinking. So sentence makes sense, right? So proteins, just like English literature, English alphabets, proteins are 20 amino acids made up of 20 different types of amino acids. Now, in these 20 different amino acids, this portion is very similar. Carboxylic H in all 20. So how does these 20 amino acids differ from each other? That differ in the fourth thing, which is called as R group. What does R refers to? So R refers to R refers to side chains. So 20 different amino acids that differ from each other by R, which is referred as side chain. So in case of amino acid alanine, the R chain would be, in case of alanine, so one of the amino acid is named as alanine. And this, in the case of alanine, R would be CH2 and CH3. So it's difficult to write the exact chemical formula, but so let me go to the Google to show you exactly what exactly chemical structure of alanine would look like. So first, look at amino S 20 amino acids. So there are various ways to write, but let's look at one of the tables like this, one of the charts. So you see here, they all have same. So here it is NH3, NH2, it depends. So let me, so this one. So NH2, so alanine, it has CH3 as side chains. So the red things, what you see here is the 20 amino acids, and rest are same. So going back to my slide share. So alanine is an amino acid where the side chain is R is equal to CH3. So it is not, I wrote here CH2, CH3, no, that's not right. The right R in case of amino acid alanine is CH3. So this question was, I believe, question number 12. What is the structure of amino acid? So I shared with you the general structure of amino acid, and then we talked about a specific structure of alanine, and we also mentioned that there are 20 amino acids that differ in side chains, and in case of alanine, the side chain is where R is equal to CH3. CH3 is generally, so this is not right. Alanine R is CH3. Okay, so let's go to the next question. So next question is, draw the structure of nucleotide with adenine as a nitrogenous base. Okay. So first, what is a nucleotide? So nucleotide. So a nucleotide is made up of a sugar. What sugar? This sugar is ribose. So how many carbon atoms in ribose, carbon atoms are 5. In glucose, the carbon atom is 6. There are 6 carbon atoms in a glucose molecule. In a ribose molecule, there are 5 carbon atoms. The second is phosphate, PO4. This phosphate, it gives rise to, that makes DNA and RNA negatively charged. Makes DNA and RNA negatively charged. So if I ask you a question that how or why does a DNA and RNA, they are negatively charged, that negativity, that negative charge is given on the DNA or RNA or any nucleic acid by phosphate molecule. Phosphate molecule is made up of a phosphorus atom and 4 oxygen atoms. So a nucleotide is made up of sugar, ribose, phosphate, and third component of a nucleotide is a nitrogenous bases. Now these nitrogenous bases can be divided into 2 groups, group A and group A and group B. Group A can be, I'm just mentioning group A or group B as for the sake of understanding, but one is purines and the other is pyrimidines. So what are purines? Purines are adenine and guanine. So adenine is referred as by alphabet A, and guanines are referred by alphabet G. Okay. Now, what are pyrimidines? Pyrimidines are thymidine and cytosine. In case of RNA, where there is no, in case of RNA, there is no thymine or no thymidine. So RNA has, instead of thymidine, RNA has uracil. Right? So nitrogenous bases, adenine and guanine, they form purines. Cytosine and thymidine in DNA, they form pyrimidines. Cytosine and uracil in RNA, they form pyrimidines. Now we all know that a DNA is a double helix structure. Double helix. Right? Now this ribbon shaped structure, the ladder or ribbon, they are called as backbone of DNA. Backbone of DNA. This is ribbon shape. And what is a backbone made up of? So a backbone is made up of sugar and phosphate. So a backbone is made up of sugar and phosphate. Now, what is the chemical, this is a very important question. What is the chemical bond that links sugar and phosphate? This chemical bond is called as phosphodiester bond. Phosphodiester bond. Now, let me recapitulate. So the question was, what is a nucleotide? So nucleotide is the building block for nucleic acids. How many types of nucleic acids? There are two kinds of nucleic acids, RNA and DNA. RNA stands for ribonucleic acid and DNA stands for deoxyribonucleic acid. Now these nucleotides, whether it is RNA or DNA, it is made up of sugar, phosphate, and nitrogenous bases. Sugar is ribose, and I'll come to it later in next slide, that ribose is part of RNA. Deoxyribose sugar is part of DNA. That's why DNA derives its name from sugar. Deoxyribonucleic acid. And RNA also starting name, part of the name is ribo. So it comes from ribose. So deoxy and ribose. So this nucleotide, regardless of DNA and RNA, the basic is ribose. Phosphate, what is the role of phosphate? Negatively charged. And then the third component, which is very important, is nitrogenous bases, purines and pyrimidines, adenine, guanine, cytosine, and thymidine in DNA. In RNA, there's no thymidine, it's uracil. Now, the bigger question comes here that okay, DNA is double-stranded. How are these two ladders held together? So these ladders, they are held together by staircase type structure, right? Staircase like this, all over. Now, how does this staircase is formed? This is formed by when adenine, it forms double bond with thymine. When adenine forms double bond with thymine, one of the ladders could be due to formation of bonding between, chemical bonding between adenine and thymine. In between guanine and cytosine, there could be, in between guanine and cytosine, there are 3 bondings. 3. So between adenine and thymine, double bond. Between adenine, guanine and cytosine, triple bond. Now I'm talking to you double and triple. What are these double and triple? So these double and triple are hydrogen bonds. So how many types of bond have I shared with you right till now? One is ionic bond. Ionic bond is formed by loss or gain of electrons. Ionic bond, like sodium chloride, common salt. The second is covalent bond. Covalent bond is formed by sharing of electrons. And this is the third one, hydrogen bond. So out of these 3 bonds, ionic bond is the strongest bond, followed by covalent bond, and followed by hydrogen bond, 3 bonds. So this in a nutshell is the structure of nucleotide. Now I mentioned to you the structure of adenine. Okay, so let's go to because it's difficult to draw. I could have drawn in face-to-face class, but here, let's say structure of nucleotide. So if you see this structure, what do you see here? Phosphate. I can't draw on this. I don't have too much of options to draw this kind of structure. I could draw in the face-to-face class. So this is phosphate. You see, phosphate has negative charge. Because of this negative phosphate, the net charge on nucleotide is negative. Look at sugar. So this is a DNA. Why do I say DNA? Because the second carbon atom only has hydrogen. There is no oxygen here. So this is deoxyribose. This is not ribose. So be careful with this. If you see, so this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. The carbon number 2 has only hydrogen. It is deoxyribose. And this is the adenine. So look, adenine, if you see there are 2 rings in adenine, one big and little smaller, double ring structure. So let's look at another example. Yes, so look at this, sorry. So if you can see this structure, so this is cytosine. Cytosine is a pyrimidine, I'm sorry. Cytosine stands for by C, alphabet C. Thymine stands by T. And uracil, which is present in RNA. So these are single ring structure, smaller. And purines are, look at the size of adenine and guanine. These are double ring structure and they are heavier, bigger than the pyrimidines. So if there's a question comes, which one is the bigger molecule, purines or pyrimidine? So the answer is purines because they have double ring structure. So, and this is single ring structure. So let's go to the next question. So I went in detail, draw the structure of nucleotide with adenine as its nitrogenous base. Now this I mentioned to you before, what are the building blocks of protein, amino acid? What are the building blocks of carbohydrate? Glucose. Lipids are generally very diverse molecule, but some books will say fatty acids and triglyceride. Here this should be not nucleotide, but rather it should be nucleic acid. So the building block for nucleic acid is a nucleotide. In case of DNA, it will be deoxyribonucleotide. In case of RNA, it will be ribonucleotide. 15th question is, why there are no building blocks for lipids like protein? Yes, there is building block for lipid, but lipids are very diverse molecule. And a common backbone is shared in proteins, in carbohydrate, glucose, and in nucleotides, common. But in lipids, because it is so diverse, cholesterol, steroids, prostaglandins, saturated and non-saturated fat, that really there is no, but most of the metabolism book that deals with eating of like butter or vegetable oil, they will talk about fatty acids and triglycerides. Now, what is the difference between the type of atoms present in amino acids, glucose, and nucleotides? So this is interesting question. If you look at the atoms that are present in an amino acid that I drew earlier, amino acids have carbon, hydrogen, oxygen, and nitrogen. These are the atoms that make up the amino acid. If you look at glucose, glucose has carbon, hydrogen, and oxygen, 3 different types of. Now, a nucleotide will have carbon, hydrogen, nitrogen, oxygen, and phosphorus. Where does phosphorus comes in nucleic acid? In nucleic acid, the phosphorus comes from phosphate group that gives negative charge to the molecule. So these are the atoms that are present in amino acids, glucose, and a nucleotide. So now question number 17. 17 and 18, let's do together. What is the difference between a covalent and an ionic bond? Give examples. So an ionic bond is formed by loss or gain of electrons, right? And this makes either a negative charge negatively or positively charged ions. And these ions, these opposite charges, they attract each other, and this force is called as electrostatic interactions. So an ionic bond is formed, and ions are formed by loss or gain of electrons. And when they attract each other because they're opposite charged, the force that attract opposite charges are called forces that are called as electrostatic interaction. And the example for this is, the most common example is our common salt that we keep in kitchen all the time in all the food, sodium chloride, common salt. Here, sodium is positive, and chlorine is negatively charged. So sodium is positively charged because it loses an electron, sodium. And chlorine, it gains an electron, so it becomes negatively charged. So they attract each other and they form a bond called as chemical ionic bond. A covalent bond is covalent bonds. They're formed by sharing of electrons. And what are the examples? Examples are most of the biomolecules. They are formed by covalent bonding, by sharing of electrons. Most of the biomolecules. So we took care of question number 17 and 18, I believe. Let's check. Yeah. Now, question number 19. How many molecules are generated from a glucose molecule? Let's say we consume bread. Best example of carbohydrate. When we consume bread, the bread is a complex carbohydrate. You get it from wheat or grains, and this bread is broken down in our body into a smallest unit called as glucose. And then glucose enters into metabolic pathway. And when glucose is completely digested, this glucose generates 36 ATP molecule. So when we eat something, we feel good depending upon what taste we like, but that doesn't give us energy unless the food is completely digested from glucose until ATP molecule. So ATPs, adenosine triphosphate, they are the currency for energy. So let's go to the next question. Name the bonds that connects two amino acids. So I mentioned to you that in English literature, there are 26 alphabets. In the world of proteins, there are 20 amino acids. 20 amino acids. So a protein could be formed from 10 amino acids or 3,000 amino acids, right? It could be a various, just like a word, it could be made of 2 alphabets, like 2 alphabets, or it could be made up of a 10 alphabet, a word. So likewise, a protein could be made up of 10 amino acids. So how 2 amino acids are connected? So the 2 amino acids, they're connected to each other by a bond called as peptide bond. And this peptide bond, so I won't go into the detail, but to be specific for this question, 2 amino acids in a protein is connected by, 2 amino acids are connected in a protein by peptide bond. Question number 21st. What are purines and pyrimidines? I already described you. Purines are adenine and guanine, and pyrimidines are cytosine and thymine in DNA, cytosine and uracil in RNA. Now question number 22nd. What are the differences between DNA and RNA? So this will be, and I will answer 22nd and 23rd. How many hydrogen bonds are between A and T together? So let's go to the last 2 questions. DNA and RNA. So the building block, you need to remember what are the building blocks that makes is nucleotide, and what are nucleotide made up of? They are made up of sugar, then phosphate, and then nitrogenous bases. The sugar in case of DNA is deoxy ribose. Sugar in case of DNA is deoxyribose. In case of DNA, in case of RNA, the sugar is ribose. Phosphate is same in both. In DNA and RNA, phosphate is same. Nitrogenous bases in DNA is ATGC, whereas in RNA it is AUGC, right? Now let's go more deep. Let's look at the difference between deoxyribose and ribose. So in deoxyribose, carbon number 2 do not have oxygen atom. In DNA, which is called as deoxyribonucleic acid, the ribose on the second carbon atom don't have oxygen, whereas ribose, it has oxygen. So let's go to the internet. So look here. Sorry. Yeah. So look here. Deoxyribose. Focus on this. Focus on this one. Second carbon atom, only hydrogen is there. So this is deoxyribose. The second carbon atom in ribose, it is OH. Okay. And then what was the next question? What are the last question was how many hydrogen bonds between A and T? So A and T stands for adenine and thymine. The number of hydrogen bonds between A and T is 2, double. And the number of hydrogen bond between G and C, guanine and cytosine are 3. So this takes care of all the questions. Okay, now give me a second. So I will go very systematically regarding asking questions. So remember in the first class, I went from A to Z alphabetically from alphabet A, student with alphabet A, name with alphabet A to W or Z. Now I'm going from Z to A. So you could unmute yourself. Kevin Williams, do you have a question?
Yeah, I just wanted to ask if you're gonna put this video so we can actually go back and reference it
Yes,
later.
if so this video is almost 1.5 hours long. It's a big video. If I can, I would like to do that. So unless there are some error.
Will it be on here or on YouTube?
Blackboard. I'll upload on the Blackboard.
All right, no problem. That was it. Thank you, Professor.
Yeah. But this is 1.5 hours. I'll try to. It takes time to process on YouTube.
Yeah.
But I would like to do it as soon as possible.
Okay, no problem.
Diana Wheeler, you have a question?
No questions.
Okay, great. Deborah Watson? Deborah? Okay, Deborah, if you're hearing me, then you can come at 6:30 session as well. If you have question, you can go over this. Crystal Vitalis?
I have no questions.
Okay. Ture Nene? Ture Nene, you have a question?
Hello, yes. I have
Yes.
a question.
This is Ture Nene?
Professor, I have trouble. Yes, it is to NNA. I have trouble from the first session on Monday. I'm not being able to connect on Zoom with the laptop internet. So I just did the phone today. I'm just listening, but I cannot see what you've been, doing. So I don't know how can I connect because I'm putting Zoom the link you gave me, but I'm not being able. I don't know how the other people get a chance to connect, but I'm not being able.
So maybe just download Zoom. Or if you already have a Zoom, just remove that Zoom and again download it.
Oh, so remove it and download it back?
Again, yes.
Okay, so I'm gonna come back. You have the next section at 6:30, right?
Yes, come back. Revise.
I'm gonna try to, but okay. But I have another question. This is the only way we can contact you by the Blackboard because sometimes I don't get no answer from you. I don't know. Do you have any number we can call, or you don't want anybody to call?
Email is best because
okay.
I'm not only teaching, so I'm giving 2 hours, more than 2 hours every day, Monday to Thursday for office hours. And if you have a small question, then I can respond by email. But most of the 90% of the teaching material are on the Blackboard. It's just the live meeting.
Yes, I see.
So just I believe remove the pre-existing Zoom and then download again.
Okay. So you said the session is 2 times a week, or is Monday to Thursday?
Monday to Thursday. All these informations are on the Blackboard. So you are Ture Nene, right?
Okay.
You're Ture Nene, right?
Yes, Ture Nene.
Okay, good. Okay. So come back at 6:30.
I have another question.
Yeah, go ahead.
Yes.
Go ahead, ask.
Hello?
Go ahead, ask.
Oh, okay. What are
Say again.
the assignment we did yesterday? We're gonna have the grade on the blackboard for it.
Your voice is echoing, so I can't make out. Even my
The
voice.
assignment, this one we're just doing. We uploaded it yesterday, right?
Yes, I'm reviewing it.
You're gonna correct them, and we're gonna have a grade for it.
Yeah, but since I'm reviewing it, I will be correcting it during the weekend. But
Okay.
so I'll try to do my best.
Okay. Thank you. That's all. Thank you.
Welcome. Stout Glory.
Yes, I don't have any questions.
Okay, thanks. Smart Rachel, you have any question?
No, I don't have any questions.
Roy Tishan, you have a question? Brianna Rowe?
No
you have
questions.
Any... Okay. Tara Powell, Miss Tara Powell?
No, I don't have any questions. How long is the test going to be?
Very quick, maybe
Okay.
half an hour, multiple choice questions.
Okay, is it timed?
Yes, it is timed.
Okay, that's it.
Monday, okay?
Yes, Monday.
Francis Odurago, questions? Anika Noble?
No questions.
Okay, thanks. Tatiana Nelson, any question? Tatiana, question? Majori? Shian McClurklin? Maya Fedora, question? Emma Mansare, any question?
Yes, Professor.
Go ahead.
When is the exams on Monday?
It will be, it will be displayed for whole day, but the time would be just depending upon the number of questions.
Okay, then.
So you could take
number...
you can take any time, but let's say half an hour, 1 hour, depends upon the number of the question. I haven't made the question yet.
Okay. The other question is, I send you an email due to the topic I want to write about for the presentation. You never respond.
Because I didn't get it.
On email, Professor.
Yeah, I didn't get it.
Okay, I will email you back.
Yeah. If you don't hear from me, then I didn't get it.
Okay.
Jade Luke. So what happened in the past month, I was writing letters for students. Sometimes emails sometimes get clogged in the filter. Sometimes it fall in the crack. I don't know, but I try my best to respond within 24 hours or maybe very quickly. But if you don't hear from me, you should remind me. And still, if you don't hear from me, which means that I'm not getting your email.
Okay.
And that's the reason I have 2 live sessions, 12 to 1 and then 6:30 to 7:30.
Okay.
Right? So you can ask questions. And if you want to talk to me one-to-one, then you could wait longer a little bit and then we can talk one-to-one. Alicia Lindo, questions? Faustia?
No question.
Okay, great. Raphael Lee? Crystal Killam?
Hi, yes, I have a question about the
Sure.
video introductions.
Yeah, go ahead.
My video won't show, but the audio plays. Is it fine to just submit the audio?
Your video doesn't work? Or what's the problem?
like I took the video, but when I try to submit it, I could only hear it and not see it.
Let me see. I haven't looked at it yet.
Because I didn't submit it yet. I'm asking you, is it okay to just submit it with the audio?
I mean, I want to see, because these electronic things are very variable. If I see you and you're talking and something is, then I can understand what's the problem. So you have to upload.
Okay.
Okay. So, Kane Abu Bakri, Devian Johnson.
Hi, Professor. No question. Thank you.
Okay. Abria Johnson.
Hi, Professor. No question at the time. Thank you.
Okay, welcome. Chizoe. Gail, any question?
I'll come back to you at 6:30. I had my test I had was to rush because I had to work and I got home late. And even the video I finished like 11 o'clock last night. I didn't even review it or anything. I just sent it. But everything was sent and everything was done in rush.
Okay.
In a rush. Okay, but it was done. But I'll speak to you at 6:30.
Sure. And let me just, I have mentioned this to many students. So these videos, you could upload. So everywhere now, your interview, your communications, your formal communications are going to be electronics. So the same videos, if you have made it with time and great attention, then you can use those videos to introduce yourself, and that will be very impressive for anybody to listen about you, listen about your hobbies, and also about your introduction, written introduction about yourself. So, these exercises or these assignments have been given to you with that perspective in mind, so that you can hold on to this video and add to your resume.
Professor.
Yes. May I know who are you?
No, this is Gail.
Okay, Gail, yeah.
When would the test be ready, the test for Monday?
It will be given all over the day, but the time limit will be, let's say, half an hour or 1 hour, depending upon the number of questions. So anytime you take it, it will be given just for 1 hour, okay?
And can we go back to the question, or once we finish the questions, that's it?
I have to look at the options. I think you can go back, but I'm not sure.
And it's multiple choice?
It's multiple choice.
Okay. Okay, I'll come back on at 6:30.
Okay.
Thank you.
Welcome. Brianna Amoy. Kayla Frazier. James Fitzgerald. Ron Bans. Evers Germain.
No question.
Okay. Sylvia Digluski. Sajay Daniels.
It's Sage.
Sage Daniels, question?
Yes, I have two questions. I'm not sure if you already addressed the first one, but for assignment 1, I didn't set up a link, so I just emailed it to you.
So why could we talk about this at the 6:30 meeting if you have time?
Yes, I could try to make it for the 6:30 meeting.
Okay.
And my second question was, I'm not sure how to upload the video. I'm trying to upload it now. Right now, I'm uploading it to my Dropbox because I tried to email it to myself and save it to my computer, then upload it, but I'm having complications doing that, so I'm not too sure on how to upload it.
Okay, I will look into it 6:30, but these, we had, just to remind you, we had a whole week, Monday to Thursday, Monday to Wednesday to upload. You could have asked me this question between Monday to, and we had live sessions twice a day. So we'll anyway talk about it at 6:30. Shania Cox. Aisha Thomas Cooper. Any questions? Okay. Kaimor Clark. Dikwan Christopher.
Yeah, I'm here. I don't have any questions, Professor.
Okay, welcome, thanks. Josephine Burrell, any question? Nikhil Bhutani, questions?
Yeah, hi, Professor. I have one question.
Go ahead.
So it's regarding the presentation list. I see in the announcement it says that we're required to attend. Does that mean we have to attend all of the sessions or just our own?
Definitely you have to attend. So I'm keeping this time. So let me give you an overall statement. I don't think CUNY has an attendance policy. And but this is, I'm doing this during office hours. So of course you have to be present during your presentation. And,
Right, of course.
And there is a balance here. So if there is a live session, because again, if you don't attend this session, let's say, and you keep emailing me regarding how to upload, I think that it's better that you attend live session, because I can only write an email. But in live sessions, you can come and I can go to Blackboard and I can show you how to submit something, how to download something, how to upload something. So do you understand what I mean?
I do, but so we are not required to attend other people's.
You should attend. Yes, you should attend.
All of them.
Yes.
Okay, but if we're not able to attend all of them, is there some sort of negative effect on our grade?
Didn't I tell you that CUNY doesn't have an attendance policy? It doesn't relate to your grade.
Sorry, I just wanted to confirm.
Yeah. So I started my answer with that question. Your question that there is no attendance policy, whether you attend one class or many classes. Yes, in some situations there are, I believe that attendance is related to enrollment verification and that has implications. So again, it's up to you.
Okay.
Salma Bari.
I don't have any questions, thank you.
Okay, yeah. Sobana Balogan. Imalika Badi.
It's Yamalicia. I don't really have a question. I just have a statement. Like with the live sessions and how we just had the review, is there any way that like when you write it out, you could space the words out a little bit more, because it kind of becomes confusing when you add like it becomes a little confusing when you add more information like on top of like what you previously wrote. So if you could like space it out a little bit more instead of writing on top of each other.
Yeah, that's the limitation of Zoom, and but I'll take note of it. And
thank you.
Yeah. Ismaila Ekinola. Yeah, so again, so let's say if you're having issues with uploading, downloading, and you are emailing me and I don't have a written protocol, but yes, if you attend live session, I can show you how things to be done. And when there is a deadline for submission, it means a deadline. Otherwise, you know, what's the point? How will I then, which means that I don't have any grading policy then, right? So that's why the live sessions are there, that email is dicey, it can reach me, it can, and sometimes if you're asking a question, which is best can be demonstrated in 30 seconds on an internet or on Blackboard, I would be wise to attend the live session. And it will be as much time in writing an email and waiting for a response And as email sometimes may not reach me, and emails may not reach from me to you. So I would encourage to attend office hours, especially in asynchronous teaching, where I will upload a lot of materials on the Blackboard. This is just the beginning. And if you want me to answer question by email, so that's the risk. So I encourage the class to attend. That's why I spaced my office hours between morning and evening, that students who are working or they're taking other classes, they can manage. And so that's the whole thing. So if, for example, let's say today's live meeting, today office hours would have been between 12 to 1, but we almost started at around 12:10, and it is 1:47, 1:48 now. And there is advantage to this, that I'm going through one question to n questions, and I'll try to upload the recording, but a recording is a recording. Again, some people can say, oh, I can't access the recording. I can't listen to the video. There are many ifs and buts. So I would, if I am taking this class, which is asynchronous online, I would take and make most advantage of live hours. An email system, I may not get back to it within 24 or 48 hours. So you have to choose. You want to keep waiting for an email response for 48 hours, or you would just come quickly for 2 minutes, 5 minutes during live office hours and get your answer question. It's up to you. So if there are no questions, I almost went through all the 45 names, 44 names. So if there are no questions, then we finish the class.
Question. Is this a
Again?
quick?
Yeah, who is
Kevin Williams? Kevin Williams.
Yeah.
Regarding the presentations, just to make it clear, I'm choosing from one of the list of articles that you have here to present on, correct?
Yes.
Okay,
So there is a presentation schedule which has your name, and next to your name is article number with red font, and then that article number is uploaded also on the Blackboard.
And where am I finding the presentation schedule? Because I don't see it. Is it under content?
Yes, under the content there is a folder of presentations.
It says informational presentation. Okay.
So let me just go quickly here.
I see the presentations, but I just don't see them.
Just give me 1 second.
Mm-hmm.
So this is summer. You go to content, and in the content you have information and on presentation and term paper. You open this and you open the presentation. Here on top it is guidelines for presentation, sample presentation, and on the top summer 2020 schedule for presentation.
Oh, okay. I'm sorry. All right, I see it. All right, thank you.
Okay. So think about, just look at this example. If you email me, oh, I can't see my presentation, and I may not be able to get back to your email. You have to give anyone 24 to 48 hours, and now you are here live. I gave the answer back to you in 20 seconds.
Got it. Thank you, Professor. I appreciate it.
So you have to make that call.
Professor, I have a question.
May I know your name?
Deanna.
Yes, hi Deanna.
Deanna Wheeler. When will this recording be uploaded on Blackboard?
So it's almost 2 hours of recording. I'll see. Not everything depends upon me. If the YouTube processes this quickly, it will be up quickly. Sometimes it takes time. So what happens that these videos have to be uploaded on the YouTube. Uploading is pretty much fast. Then it has to be processed. Processing of a video takes time. That's not for me, that's for everyone. So it depends how much time it takes.
Okay, thank you.
Welcome. Any other questions? So if there are no questions, then have a good day and see you if you have more questions at 6:30 p.m. today.
Have a good day, Professor.
You too. Bye-bye.